So a very good evening to everyone. Are you able to see the screen? RK Neeraj Kumar.
Yes, sir.
Okay, thank you. So in today's session, what are we going to do is that so first thing I as it's my personal view that for revision, first you need to focus on the current assignment that has been you have been solved. So if you want to have a good score, you have to have like good practice of the problems, and for that first you need to have solve this first all the current assignments. So in today's session we are going to see the problems of the current assignment that has already been assessed. Means you're you already got the marks for these assignments, but I think for this big starting assignment we may have forgot many concepts and many things. So we will start from the big one assignment. And meanwhile, see if you face any doubt in understanding the solution, you can ask your question in the chat box, or you can also tell to me. So let us begin with this today's session, that is revision session. And the most important thing for us get to have good marks in this NPTEL exam, that you need know how to solve the problems. So let us start with this assignment one. So in the assignment one, the first problem was the first problem is this one. So here the circuit is shown below with the convention of current and voltage. Means this polarity of voltage is considered as positive, while this direction of current, this current flowing network A, this will consider as positive direction. So here it is given that if network A operates in power generation mode, which are the quadrants of the VI characteristic it can operate. So this one is given in power generation mode. So, so if network A works in power generation mode, this voltage and current across this network A will be like this. The first case will be like this. So if this is the case, then from this sign convention, we can see the voltage is same as it is, while the current direction change. So voltage is positive and current is negative. So it lies in the second quadrant. And the next case will be this both gets opposite to the first case, so that your power will be positive. So here this voltage is reversed while the current direction is same as it is. So voltage will be negative and current is positive. And for this case, voltage is negative in fourth quadrant and current is positive in this fourth quadrant. So the correct answer is second and fourth. Coming to the next problem. So here in this problem, the equivalent circuit is shown for this PV cell, and this voltage drop across series resistor and the diode current are ignored. Means this voltage drop of cross series resistor, it means that IPV RS is 0 and diode current is also 0 in this region A of IV characteristics. What is the expression of slope M1 from the given option? So you have to find the slope M1 for this characteristic. So for this, you just write the KCL equation for this PV cell. So KCL equation will be I light equal to ID plus ISH plus IPV. So it will come as IPV equal to I light minus ID, and ISH you can write from the KVL across this loop. So VPV plus IPV RS upon RSH. Sorry, this is ISH. And then it is given that this voltage of across series resistor is 0 and this diode current is also 0. Then you will got this equation IPV equal to I light minus VP upon RSH. So we know that at VPV, when this voltage across PV cell is 0, then this will short circuit current. Therefore, this I light, we got this photo current value, light current value, that is short circuit current. Therefore, we will write the final equation. It is IPV equal to ISC minus VP upon RSH. Now we compare it with standard line equation y equal to mx plus c. So from here we will get the slope of this curve, and the slope of curve will come as minus 1 upon RSH. So D is the correct option for this problem. Now in the next problem, they want to know, they are asking about the slope M2 for this region. And here this current through the shunt resistor RSH, that is ISH, ignored in this region V of this I case of PV cell. So what is the expression of slope? So for finding the slope, you can write the KVL equation across this loop. Then you will get this one, and this RSH is equal to 0. Therefore, you will get this one equation. And if you compare with this slope of line, then you will get slope is equal to minus 1 upon RS. Now let us see the next problem, that is fourth problem. In this problem, they are asking about this value of shunt resistance of the equivalent circuit of PV module. And for this, we have to apply this KCL for this PV module. And we know that this IL is equal to ID plus ISH. And this for this open circuit condition. So for this open circuit condition, Mohanjit Abram, your mic is on. Could you please turn it off? Whenever you have doubt, you can unmute yourself and can speak. So here we are going to see what are the steps for finding this shunt resistance of this PV module. So for open circuit condition, we have written this KCL equation, and then we know the diode current is equal to this I naught into e to the power Vd upon eta Vt minus 1. So here you have to just keep in mind that this thermal voltage should get multiplied with this total number of cell. So in this problem, many of the have forget to this multiplication of number of cells. So it is very you should be cautious, and you should multiply with the number of cells. And here this number of PV cells is given a 36 number. And for open circuit, this voltage across Vd will be VOC, and this open circuit voltage also given. Now you can find the thermal voltage, and we know that thermal voltage equation is KT upon Q, where K is Boltzmann constant and T is this temperature given. So it is given 25 degrees Celsius. So you convert in Kelvin, it is 298.15 Kelvin, and Q is this charge value 1.6022 into 10 to the power minus 19 coulomb. So you will get thermal voltage. Now you substitute this value there, then this light current is also given as 3.114 ampere. So this I naught into this value will come as 3.043345 ampere. So you will get shunt current as 0.07054 ampere. Therefore, you can find this shunt resistance value as VOC upon ISH. So it is coming at 310.6 ohm. So for solving this problem, we have you just don't apply this KCL KVL across this PV module directly. You just here it is asking about this shunt resistance value. Then you apply KCL with the open circuit condition. That will be the process for finding the shunt resistance value. Now suppose you have to find this series resistance value. Then what condition you have to apply? You have to apply this short circuit condition so that this IPV becomes ISC. So this is the step for finding the shunt resistance value. You apply this open circuit condition, and for finding this series resistance value, you apply this short circuit condition. Now coming to the next problem. So here in this problem, they are asking about series resistance. Then you apply this short circuit condition, and during short circuit condition, this value of diode current is negligible, so you can take it as 0. Therefore, you can write ISH equal to IL minus ISC, and this will come as 0.0037 ampere. So apply KCL, then in short current, this diode current is negligible, and this IL equal to this ISH equal to IL minus ISC. And we know this light current value that is given in the problem 3.114 ampere, and the short circuit current is also given, so we will get 0.0037 ampere. Now we find this VSH. VSH will be this value VSH. So VSH will be ISH into RSH. So this you will get RSH you can from the previous problem. You will get 310.6 ohm. You will get this shunt voltage value. Now you can find the series resistance value VSH upon ISC. So you got VSH, so it will be IS upon ISC, that is the current value across the series resistance. So you will get 0.369 ohm. Yes, if you practice this assignment problem, most probably you will get you will able to have a good command over the other problems also.
Sir, I have a one question.
Yes.
Uh, Sir, there is we solve the problem step by step. Either there is option type question.
Okay, you want to ask that there sequential type problem means problems that are related to each other, right,
In the
Ramesh?
in the yes, in the exam there is theoretical matlab question like um, uh, objective type question. Yeah, this type of question, this we can solve thoroughly by step. Either we can put directly answer.
Numerical type or objective type, you want to ask that.
Yeah,
So
I yes.
that is means I don't know what type of question they will ask, but they will focus similar type of problems that you have solved in the assignment. They will not ask like they have not asked from the software part. So they will not ask from software part.
Yes,
But
because
but
uh,
you just be prepared like that. You will have this not objective type only. You will have this numerical type also, and you will have also the sequential type. Means one problem, three or four problems are related to each other.
I
So
am
if you have
asking, I am asking this because if there is numerical problem, then we solve that problem step by step, and the examiner who check the sheet answer, they if our procedure is correct, then he will give some marks. Otherwise, if directly we put the
no, no.
answer in the answer sheet,
This is
then
just
it will
yeah.
be
If
wrong.
you yeah, they will not look on your rough copy, right? You will get also what is that called? One seat you will get in the exam.
Hmm.
One seat that what is called? Yeah, A4 seat will be provided to candidates for rough work. I think all of you got this admit card.
Yeah, yeah, we got the
In
admit
admit
card.
card, you just read all the things, whatever things written, that will follow. This A4 sheet will be provided to candidates for rough work, and the candidates have to write their name and registration number on the A4 sheet before they start using it. And the A4 sheet must be returned to the at the end of examination. And this A4 sheet will be returned, but they will not look it on your A4 sheet means whether you have done correctly or mistake. They will look. This is the computerized type of evaluation. This computer will do evaluation. Whatever the answer you have typed, if your answer in the range of this value, then you will get the marks. Like in this problem number 5, there is no this options. There are no options given. So here you have to type your answer, and if this answer is lies in this range, you will get the marks. Otherwise, you will get 0 marks, and there is no negative marking.
Okay. They will not check the process. They will check only
Yeah, no,
answer.
this is not a subjective type. This is not university type exam. This is they will not check your process whatever you have done. There are so many students. Do you think that they will look each one of the rough copy?
Okay, got it.
It is just like similar to a little bit gate exam. In gate exam, you have negative marks, but here there is no negative marks.
Okay.
So in this problem, a PV cell with open
Sir,
circuit,
sir, I
yes,
did not receive the hall ticket.
you have written to this discussion forum.
No, I did not write, sir. Uh, but till now, I did not get.
You wrote in the discussion forum. I hope you will get the response. In which region you
Oh,
belongs? In which region you belong to? Which state?
Mumbai, Maharashtra.
So I think they are releasing in the means slot wise according to the area. So if in your area they have provided like your batchmates, uh, someone has taken this course, you can ask to them. Otherwise, you can write them to directly. You can write mail to them also. They will respond quickly.
Okay, so either in question answer session or mailing.
First, you ask in this discussion forum. There they will
Okay,
just give you. Then otherwise, you can mail also. Mail is not miss. Don't hesitate with mail. Don't afraid of mail also. It is just a
okay,
2 minute
sure.
task. Na?
Okay, I'll do that. Thank you.
Okay, welcome. So let's see this problem. So it is very easy problem. They have given this module efficiency and they are asking about the cell efficiency. So cell efficiency is always higher than module efficiency. Therefore, one is coming. So this C option is the correct option. And the next problem they are asking about the fill factor. And the fill factor of the module is given as 80%. And what is the maximum power in watts under the same condition? So fill factor is the ratio of maximum power upon this ideal maximum power. Ideal maximum power can be VOC into ISC. So this maximum power you will get from this equation. You will get 1433.6 watt, and the range they provided is this one. The next problem we are here they are asking about this. Uh, they are asking about this value of ISC at 50 degrees Celsius. So you need to know this temperature coefficient for current. So voltage coefficient they have provided 0 minus 0.34 percentage per Kelvin, and this for current it is 0.045% per Kelvin, and this power they have provided 0.47% per Kelvin, and the values they are given at STC standard temperature condition, that means 25 degrees Celsius. Since this current has positive temperature coefficient and your value at this standard temperature condition is 6 ampere, so you will get at 50 Celsius is always higher because it is positive temperature coefficient, so you will get this one 6.06 ampere. So you remember this temperature coefficient expression, change in ISC upon ISC at given value upon delta T into 100. So it is quite easy. Similarly, they have asked in the next problem, what is the value of open circuit voltage at 50 degrees Celsius? So again, you apply this expression for voltage. Voltage coefficient value will be changed in VOC upon VOC at 25 degrees Celsius upon delta T into 100. So VOC at 50 degrees Celsius you have to find, and this VOC at 25 degrees Celsius is given as 23 volt. So here is 23 volt they have given. So you can find that open circuit voltage at 50 degrees Celsius. So since this voltage coefficient has negative temperature coefficient, so this value will be lesser than 23 volt. So it is coming as 21.045 volt. coming to the next problem. What is the value of maximum power? What is the value of maximum power in watts at 50 degrees Celsius? So this value is coming as, so again you have to apply this expression for power coefficient. So it is similar to VOC temperature coefficient and ISC temperature coefficient, that is change in PM upon PM at 25 degrees Celsius upon delta T into 100. So upon simplification, you will get 91.78 watt. So this power is also negative, sorry. So temperature coefficient for power is also negative, minus 0.47. That's why this value is coming lesser to this 104 watt. The NPTEL uploaded solved weekly assignment in the NPTEL software I can find. Yes, they have uploaded. You can go SWAM portal. In SWAM portal, you go to announcements. You go to announcement and find the solution. So this one is for big 12, and again you go further. Then this is for big 11. Again you go further. So you go big 10. So you will not get in this tab, this left hand side tab. They have means earlier they used to give here also, but nowadays they are not providing this part. So you have to go to assignment and search this solution, all the solution, and they have given through the link.
Please open one, sir. Anyone?
Yes, like this one.
Okay, got it.
So I
Sir,
would
how?
suggest that if you want to get more marks, then you just solve the more problems. If you solve more problems, you will get good marks. Otherwise, whatever theory you know, that will not be beneficial in the exam. Theory is beneficial for concept only, but you don't have command over the problem, then you will not able to solve there also. If you know the formula also, you will not able to use in the exam if you have not solved the problem earlier.
How many questions are coming in the exam, sir?
In your hall ticket, they have not given the number of problem. Total duration is 3 hours, but I think they have not given about the number of problem.
Generally, how many questions they are asking?
I'm whatever things I am saying, that is not uh, confirmed. So, it is, I think it may be 50, 60 problems. More than that. More than that.
Okay, more than 60 questions. And each week assignments, they are asking minimum 3 to 4 questions. I hope so.
Yeah, they will cover all the part. They will not leave any part. Means you have to go through all the syllabus. If you just solve some parts, then this is not, some part you will miss in the exam.
Okay, I suppose if we command over 5 to 6 week assignments throughout command, good command, then we get the pass the exam.
I would suggest that you go, you cover all the syllabus, not just half of them.
Just asking because now we have very short
Yes, the
time.
syllabus is large, but you just focus on the problem, not focused on the video lecture. This is my suggestion. It is not take it as confirm. Solve more problems, you will get marks. Otherwise, whatever, otherwise the thing, this theory will not work. You have good notes, but you don't know to solve problem, then that will not work. For any general exam, this is the case. And I would suggest that don't left any any section, because some problems is easier in every section. Now suppose easier question they will ask from any part, then you will not able to get marks. So just go through all the assignment and all the whatever the tutorials and all this, so that you can at least have at least able to get marks in easier problems. Otherwise, you suppose you completely escaped 1 or 2, means 1 week or 2 weeks, 3 weeks more than that, then you will not able to get the marks in easier problem also. Like these parts, this temperature coefficient, I have shown you this problem. So this problem, you know this simple expression, then you will able to solve it quickly. But for a means for a poor student, like they don't know to get this shunt resistance value or series resistance value. So this is little bit average problem, not easier problem. So you can escape this one. But they ask you very easier like this fill factor. If you escape this section first big, then you will not able to get marks in this easy problem also. So this is very bad. Actually, you should just revise all the parts so that you can get marks in easy problem. And if you have good command, then you can get marks in average and complex problem also. So my suggestion that you just go revise all the section so that you can get marks in easier problem at least. And many problems are easier and some problems are mediocre and little bit problem are hard, means tough. This is general for every exam. Understood, Ramesh?
Got it, sir. Thank you.
Yes. So coming to the next assignment. So in this assignment number 2. So here we have seen the series and parallel connection of PV cells. So here this first problem, these 7 identical PV modules are connected in series. So this problem is from series connection, and the load line intersecting this IV characteristic of one PV module is shown below. This is the IV characteristics. They are asking about total power that this series connected PV module deliver under the same external condition. So if 7 modules are connected series, then what is the VMP equivalent, the maximum power equivalent? This will get multiplied with 7. So this VMP equivalent will be 210 volt. So if we have series connection, this voltage will get multiplied with the number of modules. So VMP equivalent will be n into the number of self-connected series into this this maximum power voltage for this for each module. So it is 30 volt given. So this is VMP and this is IMP. So IMP equivalent will be same because these modules are connected series. So it is 5 ampere. Therefore, this output power will be 210 volt into 5 ampere. So it will be 1050 watt. Now in the next problem, one out of 7 modules comes under this partial shading. This causing this IV characteristic of the partial shaded PV module to change as shown in this figure below. So this one module comes under power shading, and this IV characteristic of this partial shaded module is given here. What is the total power that the series connected PV module string supply under this partially shaded condition for the same load current? So we will just do separately. For this unshaded part, the maximum power point voltage will be, since this series connection, so it gets multiplied with the number of number of modules. So it is 6. So it is 180 volt. And for shaded part, it will negative. Why this negative? Because it has a negative voltage contribution. So if the module connected series, so it will have negative voltage contribution. And if the module if module is connected parallel and if they bend into partial shading, then that module have negative current contribution. So now equivalent voltage will be unshaded voltage plus this shaded part module voltage. So unshaded is 180 volt minus shaded part will contribute this negative voltage contribution. So it will be minus 15 volt. So this total maximum power point equivalent maximum power point voltage is 165 volt. And this maximum power point equivalent maximum power point current will be, it is same, 5 ampere. So this P out will be 165 into 5. It will be 825 watt. Now the next problem. In this problem, they have connected an anti-parallel diode. So you are protecting this module, and you bypassing the shaded module. So if you bypass the shaded module, this VMP equivalent with 13 to 6 volt, and this negative part will not come into this maximum power point voltage, and this maximum power point equivalent maximum power point will be same. So this maximum power equivalent maximum power point maximum power will be 180 into 5, that is 900 watt. So what you have seen here, you have seen here that this power in case of all unshaded, is greater than this power with with this anti-parallel diode. Shaded module with anti-parallel diode and this shaded module with no diode, with no anti-parallel diode. So you can easily get understood. If the shaded module is there and anti-parallel diode is not there, there is no bypassing part, so it will have a negative factor. So this will lower down the power power coming from the PV modules. If they have bypassed this shaded part, then this power coming out from PV module will increase. And if there is no unshaded part, then there will be maximum power we will get from the module. So these three problems we have seen for the series connection. Similarly, we will see for the parallel connection. Power converter and charge control comes as single circuit or two different circuit. So you are asking about the battery with PV, right? Rajnikant? Rajnikant, are you able to?
Sir, actually, my doubt is that,
Yes.
sir, actually, we are implementing MPPT in the power converters to track the maximum power from the PV module. At the same time, we are charging the battery also. So, are we incorporating this MPPT and charge control together as a single circuit or a differently? So that's what my point.
So it depends upon, there are many types of configuration. Like if you have DC-DC converter here, and you directly connected with the battery. So you directly connected with battery and you want to draw this power from this PV module at maximum power point. So for this, we will have this current and we will take this EPV and IPV. And it will pass through this MPPT algorithm that will suppose set this VDC voltage across this PV, and that you suppose you pass through some controller and you again this take this as, and error will go through this controller. That is general structure for, and that will generate the duty cycle and that will drive the switches. So this is general structure of MPPT. Now you want to have this charge controller also. So for charge controller, you have this battery. What we need to have load also here. I can say. So here I want to say that means from one converter you are taking care of this MPPT. But whatever this, suppose this voltage across this battery. So based on this voltage, deciding the voltage level, you are feeding the power. You are charging or discharging the current. Means you are taking the reference of this battery voltage and this current also. And from this controller, you are charging or discharging the battery. So from this same, because this is what you can say, this is intermittent source of energy. PV is intermittent, so this is variable power. Means you cannot have whatever the amount of power you want to extract from the PV, you cannot extract. So first thing is that you have another external source, and I think this there will be second converter to decide this charging and discharging of battery. There should be second converter to need to be installed.
Okay, sir. Sir, I got one more doubt, sir, with respect to MPPT. So actually, sir, in MPPT, practically what are we doing is that whenever we are the output of the PV module is maximum, that time only we are keeping the switch on, and when it's falling, that's where we are switching off. Is it correct, sir, or something else we are doing, sir? Actually, practically, what's happening inside that?
What I didn't
Sir,
get, miss what?
sir, in the
Yes.
in MPPT tracking system, sir, actually the output of the PV model is uncertain, sir. Is it true or not, sir? We don't. It's depend on the insulation. If the insulation is more, the output will go high. Is it true or not, sir?
Yeah.
So in that sense, sir, so how we are fixing the MPPT means whenever the output voltage is maximum, that time we are making the switch on so that the output will goes from the PV module to the load. And whenever it's low, that time we're switching off. Is it happening this way, sir? Or how we are fixing the MPPT points, sir? Maximum power point.
This we have seen what usually we do. So let me just. So this is IV characteristic, and this one is the PV curve. So BR generally means there are many types of controller. Some controller may provide this DC reference, this voltage reference, and some controller they may provide this current reference. So we are tracking this point, and for tracking this point, we apply. There are many types of method, and thus one common typical method is P and O method, perturb and observe method. So we want to track this point. So you are setting this voltage. Means if you set the voltage across PV, this one VMP, then you can extract this amount of current IMP. So you will get this maximum power from the PV module. And since this PV is variable power, it is not on our demand. So this PV, suppose this insulation goes down. So this will be like this. This IV curve will be bent like this, and this curve will also bent like this. So when this curve goes down, then this our voltage across this PV, we have to set this one. Earlier this one VMP1 and this VMP2. So based on the insulation level, it goes down, and this maximum power will also coming to different. So it is decided by this MPPT algorithm. MPTP algorithm takes care of the insulation also. Takes care of the insulation also. Rajnikant, what you have doubt means if your insulation changes, then the voltage across you are setting across this PV is also getting changed. So this power you are expecting from the PV is also getting changed. Rajnikant, are you able to get it or not?
Sir, actually, my assumption is that every time, sir, the fluctuating happening me in between what are the rest of circuit is doing, sir. Suppose when the insulation low reduces, sir, so automatically my PV curve is falling down. So in that period, the converter parts, sir, that which is supposed to control the duty cycle, actually duty cycle sensor where we are making a transistor on and off on. That's what is happening. Is it true or not, sir?
Yeah, for means like the insulation is changing at a faster rate, then your converter should respond to that scale also. If your converter is slow, then how it will track that power?
So
It is true.
technically, the how we are picking up
Yeah.
it. Sir, my
Yes.
points in a layman way, sir. My understanding is that to get that to the peak point on the PV curve, I think the control the loop that the control circuits, whatever the loop system is working to find out when my output of the PV power is maximum. That time my switch will become on. Is it true or not, sir?
No, no, it is not true. You are getting in wrong way, miss. You are not understanding. Means whenever the power from the PV panel is maximum, when it is maximum, it depends upon you. Then what amount of power you want to extract from the PV. So based upon the if you have set the voltage different from this maximum power point voltage across PV, then it will give the less power or a different power. It is not true that you are turning on the switch when and turning on the switch is different. Means like there may be different types converter. It may be have 2 or 3 switches. So it depends upon the single phase or means it depends on the AC or DC converter also. So, but you don't think like that you are turning on the switch. You are just said that this DC-DC converter set the voltage of current level to this PV. Means what means set the voltage level across this PV such that this maximum power can be extracted. And this this DC-DC converter decides what amount of power you want to extract. And this maximum limit is at this point, this PM. You are getting incorrect way.
Sir, actually, sir,
And
suppose we take an example, sir. Suppose my PV model voltage rating is 48 volts and I say current is 5 amps, sir.
yeah.
So suppose I want charge a battery with a 40, say, sir, for example, we'll charge with 48 volts, sir. I want charge it as it is, means I put more batteries in series with the 5 amps current. Suppose due to my insulation is low, so I don't get the 48 volts. My output of the model is fall down to say 30 volts. In that case, how much that control loop system will work, sir?
You want to charge your battery at 48 volt, right?
Right, sir.
Yeah. So the this if this single stage, then it depends upon the power that you are extracting, and there may be there may be limitation on the power. Means if it's not able to deliver, then it will have different charging rate for the battery. But if you are having another source, then you may think of charging at the desired rate. Means at some infinite source of energy, like you have some connected to the grid, but here is PV, so this power delivered to the battery should always be lesser than this maximum power.
Suppose we'll avoid this battery part, sir. Just to talk about that MPPT part. Suppose I said that my the peak power is say we can say select 48 volts. I will get the maximum power, but my insulation is low, so I am getting only output of the PV model is 30 volts. In that way, in that time, how my MPPT algorithm will work, sir?
Okay, you are setting that this part of DC-DC voltage is not getting. Yeah, I got your point. I got your point. Okay, now I just so this part is not the desired voltage, so that you cannot set this voltage. Yeah, correct. So if this voltage is having set by battery, and this battery SOC is lower, then this voltage is also lower, and then based on this converter duty ratio limit, you cannot set this voltage at this maximum power. So in that case, you have to work the PV at derated MPP. So one term is come as derated MPPT. And in Bhimsing paper, in Professor Bhim Singh sir paper, you will find this term more frequently. So you are not operating your PV at MPPT but has lower value, that is below the MPPT value, because this voltage in this converter will not operate at the duty cycle, because this voltage should be fixed, because this converter can set one voltage level. If you are setting this voltage across the PV, you cannot set this voltage across another part also. So one part of this voltage should be fixed. So yeah, correct. Sometime we have to operate the PV at an unrated value.
Thank you, sir.
Okay, I think we have discussed a lot about this. So this actually the course, this type of courses are research means more focused of higher means they are a PG type or means research focused. That's why some you have to think more beyond, like there are many configuration and there are many things can be possible. So let us come to the assignment part. I have already solved problem, so that will not take time. Just you go through all the problems, and I will just give a short summary in each problem. So now coming to the parallel connection of cells, parallel connection of module. So here a PV array has 50 numbers of PV modules, and it has 5 numbers of PV modules connected in series to form a string, and there are 10 such strings connected in parallel. So the PV module connected series that will decide the voltage level. So 5 modules are connected in series. So this VMP equivalent will be 5 into 33, because this maximum power point for each module is 33 volt. So it will be 165 volt. And this 10 such strings are connected in parallel. So this equivalent maximum power point current will be 10 into 2.5. So it will be 25 ampere. Therefore, this equivalent maximum power point voltage is 4125 watt. You get multiplied with this VMP into IMP. Now in this part, there is no shaded part. There is no shaded PV module. Now in the second part, it is asking that one string comes under partial shading and causing the IV characteristic to follow this IV part. So in this condition, what is the maximum total power shared by the PV array? So as I said in the earlier part, for the series connection, if this sum module goes into shading, partial shading, then it will have this negative voltage contribution. And for this parallel part, if this one module goes into shading, then it will have negative current contribution. So IMP shaded is minus 7.2 ampere as shown over here, while unshaded will be 9 into IMP, because one module goes into shading region. So IMP unshaded will be this 22.5 ampere. Now this equivalent power from the module, total power shared by PV array will be VMP into IMP unshaded plus shaded. So you subtract this shaded current from this total current. So you will get 22,524.5 watt. Means shaded string is acting like a sink, either in series or parallel connection. Now you have used this diode in series to testing to prevent power sink scenario. Now you have connected diode to prevent this power sink scenario. So in that case, this negative part will not come, and this maximum total power will be VMP into IMP unshaded, and this IMP unshaded will be 9 to 2.5, and this will come at 3,712.5 watt. So I hope you got about this parallel line series connection of module. This is quite very easy problems. For shading part, you have to take care of, the power will be less, and one part will be act as a sink. Therefore, something should be subtracted. If there is parallel connection, then the current should be subtracted. If there is series connection, then voltage should be subtracted. And you will get the total power from the PV array. Now in this question they have given this current gain. So current gain is IC upon IB. From here you will get this base current value. So base current value will be 25 milliampere. And now you can find this this minimum resistance of this base resistor from the KVL across this voltage. So V source minus IVRB minus VVE. So this minimum value of base resistor will come as 972 ohm. Now in the same problem, they are asking about at what angle this base voltage supplied by the rectifier voltage source that the PV operator maximum power point. So let us assume this PV is operating maximum power point. So this IC will be equal to IMP. So IC equal to IMP, and this IMP is given as 2 ampere. So this you can find from here base current. So base current, this base current will come as,
What is the HFE in question
this
number
is the
7?
current gain value. They have given
HFE.
the, yeah, this is given as current gain of BJT.
Okay, okay, got it.
So in this basic electronics part, we know about this beta equal to IC upon IB. So they have given this term current gain as HFE. So you can correlate from there also. Beta equal to IC upon IB. So this is similar. So from here, by using this current gain value, you can find the base value is 20 milliampere. And now they are asking about the input voltage at maximum power point. So V source MP will be, so you know this IV, RV also known, VV is also known. So you will get this 20.14 volt, and this V source is Vn sin theta. So Vm sin theta, this expression, you just equate it, you will get this theta at maximum power point voltage, that is coming as 53.66 degree. Now coming to the next problem. In the next problem, they are asking about what is the load resistance value at which maximum power is transferred from DC voltage. So this is very simple problem, and we know that for maximum power point theorem, this load resistance will be equal to series source resistance, such that the maximum power get transferred. So it will be same as 10 ohm. Now this question has been eliminated from the final evaluation, but this problem is also easier one. They have not provided the circuit. So in this problem, they are asking about what is the error between the reference current and the actual load current. This error. So they are also telling that this buck converter is operating at MPP. So this input voltage is given at 30 volt, and for operating at MP VMP, this this IV character is given. So VMP is 23 volt. So this voltage is 23 volt. Output voltage is 23 volt. So duty ratio will come as V naught upon V in, that is VMP upon V in. So it is 0.7667. So this, if you see the controller, this is providing only the duty cycle. So this carrier signal, this one carrier signal varies from 0 to 1, and this duty cycle is 0.7667. So it is, if you pass this duty signal, then you will get the output voltage 23 volt. such that you will get this maximum power. You can operate this maximum power. You can implement this MPPT to this converter. And now you know this duty cycle, and they are asking about this error. So this is, so what should be the error? You can make just opposite. So this is gain and output is 0.7 and input error. So error upon 0.7 equal to, I think I done a mistake. It is opposite. 0.7 upon error equal to 1000. So error will be 0.766 milliampere. So this is for till big 2. Now coming to the big 3. So let us see the assignment 3. So in assignment 3, the first problem is very easy. What kind of energy does the flywheel storage system store in it? So we know that this flywheel will system stores energy mechanically in the form of kinetic energy by spinning this mass at high speed. So this kinetic energy is substitute of this mechanical energy. So you can say that this is part of mechanical, so it is mechanical or kinetic energy, and this is Venn diagram. So mechanical energy either will sum of potential energy, kinetic energy, or it is just uh, only this kinetic energy or potential energy. So there can be many things. So this is the Venn diagram for the mechanical energy, kinetic energy, and potential energy. Now coming to the next part, for the spectral irradiance versus wavelength characteristics shown in the figure below. Up to what wavelength is the irradiance maximum from the given option? So this area under the curve is the total irradiance with a maximum wavelength of up to Z nanometer. So we have to take this point such that it will give this area under the curve, and this we will get this irradiance maximum. And to find the area under the curve, we have to integrate for this spectral irradiance with respect to lambda. So PS into d lambda from 0 to lambda max, and lambda max we can take it as till this Z nanometer. Coming to this next point, next problem. In this problem, a storage system load requires a maximum energy of 7 kilowatt hour daily fed from solar PV panels. The power available at the output of PV panel is plotted with respect to time when the irradiance is applied on the PV panel. What is the PV panel minimum power rating to satisfy the load under ideal condition? So they're asking about the minimum power rating. So we can find the energy that being supplied by the PV panel. So energy being supplied by PV panel is the area of this PT curve. So area of PT curve will be half into base into height. So base is number of hours, that is h, and this height is P max. So half into P max into 8, and this energy. Sorry. So energy being the load required is 7 kilowatt hour. So 7 kilowatt hour into 2 upon 8 hours. So it will be 1.75 kilowatt. So this power available at the output of PV panel, and the minimum power rating is this P max, and this P max value is 1.75 kilowatt. Now coming to the next problem. In this next problem, they are asking about the what is that period for that day if this standard installation is followed throughout a certain period. we know that a standard insulation is 1 kilowatt per meter square. So this is the standard insulation, and it should be multiplied with area, and area of P panel is 6.25 meter square to get the power, and to get the energy you have to multiply with time. So the time is we need to calculate such that we have to follow the standard insulation, and the efficiency of PV panel should get also multiplied to get that amount of energy. So this number of hour equivalent to standard insulation will be 7 hours. Any problem till this part? Coming to this next problem. So in this problem, they're asking about the declination angle in degrees on August 15, 2024. Use the empirical formula discussed in week 3 lecture. So declination angle expression is 23.445 sine 2 pi into n minus 80 upon 365. And for August 15, you can either calculate from the back side, from the back of month of year, or you can calculate from the starting of the month, starting of from the January. From the back side, then you have to multiply, you have to subtract from the number of days. Since this 2024 is a leap year, so 366 days minus 31 for December, and 30 for November, and 31 for October, and 30 for September, and 15 August. So you have to multiply, you have to subtract 16. So it is coming at 228 days. And you start from the 1st January, then it will be 31 for January, 29 for February, similar go on, and this 15 for August. So it will come at 228. So delta will come as n will be substitute as 228. So we will get this value in radian 2.5477. And for this also you have to get the value in radian 0.56. So just know this you should not do silly mistakes here. Be aware of this radian and degree. So this value should be in radian, so that you will get the final value in degree. So the final value is 13.122 degree.
Sir, actually, I'm getting a maximum time confused in this three assignments, where I have to go with radians, either go with degree.
Here, if you, how I can say.
Uh, Actually, this question and many question I solved
So since
some places through a degree, some places to radians, but it's not clear where we have to solve from radians and which question solve through the degrees.
so this value should be in radian. Why this value should be in radian?
Due to the here is pi, that's why
Yeah,
2 pi.
this 2 pi term comes. This 2 pi terms comes. That's why this value is radian, and this value is other. Just you cannot. If it is, means like this minimum value 2.547, it is cannot be in degrees. So from basic sense also you can say that it is in radian. And for finding the value of sine with this radian value, so you have to set first the calculator, but in the exam they will have this in the exam they will provide the online calculator, and I think there should we have to always convert this radian into degree first. And like if you convert this radian value into degree, so it will be 180 degree upon pi, and then find the sine term, then you will get the same value, that is equal to 0.5. So this is this you have to just remember. You have to just know, take miss this is you have to just keep in mind that this value should be in radian, and you have to when you are finding this term sign with some value, then inside it is what is radian or degree. If it is radian, then you have to set the calculator accordingly, and if in degree, then you by default it is in degree, so we put 0.56.
Okay, the value is here 0.56. It
And
is in
this
radian form. So final answer, how it will
and
come
this
in degree?
and this 23.45 is in degree. So you have
Okay.
to, if you multiply with 0.56, it will come as 13.122 degree. Yes, in this big assignment 3, there you have to just take care. Chidambaram, I think I've already told, and you have to just see means in the expression whether we have to take in radian or degree. And sometime you will just know that if something I've done wrong, if you take it in degree, then its value will come very small. So this delta will also become very small. Now coming to the next problem, and in this problem they are asking about the angle between the insulation line and horizon plane is 70 degree. Considering the standard insulation incident to horizon plane, what is the insulation normal to the horizon plane? So this theta z you have to find, and this angle between insulation plane and horizon plane is 70 degree. So this angle they have given as 70 degree. First find the zenith angle theta z. Theta z will come as 90 minus 70 degree, 20 degree. Then you can find the standard insulation incident to horizon plane, normal to horizon plane. So this will be 20 degree.
70 degree
So
is the uh,
normal will be this value and this
declination angle, na? 70 degree angle is declination angle.
for declination angle. Let me see. Declination angle for finding declination angle, we use the expression. I don't think this is declination angle. You just see the textbook. Here they are asking about this LZ. So for finding LZ, this value is given. So this value is given, L is given, and this angle is given, horizon plane. So this is 70, and this LZ will be L into cos theta z. So this will come as 0.9396. Now in the next problem, at the equator on March 21 to 223 at the equator, the zenith angle is 30 degree. What is the hour angle for the given data? So equator means this latitude angle will be 0, and this zenith angle is 30 degree. For finding the hour angle, we will use this expression Lz equal to L cos del cos omega cos phi plus L sin del sin phi. So Lz we know L cos theta z. So L will get cancelled out. So cos theta z equal to cos del cos omega cos phi plus sin del sin phi. So this is another important expression. So substituting phi equal to 0, you will get cos theta z equal to cos del cos omega. Now we don't know del. For finding the del, we know the day of the year, and from the day of year we will find the n. So n will be 80, and we know that this March 21st is the spring equinox. So delta will be 0 for the spring equinox, and you can also get from the expression also. If you substitute 80, then sine 0 is 0. Therefore cos theta z is cos omega, because cos 0 is 1. So omega is equal to theta z. Therefore this hour angle is 30 degree. Now coming to the next problem. Now they are asking about the maximum duration in hours on that day. So length of day is 2 omega SR radians. So here this in the expression only they have given it is in this value radian. So if to get in hours, you have to multiply with 12 upon pi. So you will get the in hours, and then omega SR value substitute. Omega SR is cos inverse minus tan phi tan del. This is another important expression. And since phi is 0, so it is cos inverse 0, therefore it's 12 hours. And you can directly say that since this is equinox days, so day and night duration are equal, so the maximum duration is 12 hours. Now coming to the next problem. So what was the incident energy available at the equator on March 21, 2023? Consider the empirical formula of irradiance discussed in the respective lecture. So we will use this expression is not equal to 24 upon L into cos phi cos the sin omega SR plus omega SR sin phi sin del. First we will find the insulation on that day. So insulation on that day will be LS into 1 plus 0.033 cos 360 n upon 365. So we know this standard insulation is 1.37 kilowatt per meter square, and n is 80. So we will get L value as 1.3787 kilowatt per meter square. So omega SR is 5.2 radians. So now you substitute this omega SR here, and you will get H naught value. Now think here, this omega SR will be in degree or radian. Omega SR will be radian because you cannot multiply with some value with degree directly. So this value in radian. Another value it will come within 0, 1. So this value you have to take in radian. You cannot take omega SR in degree. And this value should be within 0 to 1. And this value also, because cos and sine varies from -1 to 1. Sorry, -1 to 1, not 0 to 1. -1 to 1. So let us see the next problem. In the next problem, they are asking about duration of day. So we know that length of day is 2 omega SR radians, and omega SR is cos inverse minus tan phi tan del hours, and we have to find the del first. For finding this omega SR, and phi is given -15 degree. So del can be find from number from the day of the year. So del is coming as -22.93 degree. So it will coming as minus 10 phi tan del is coming as -0.11335. So taking inverse is that 1.684 per hour. So it is 12.86 hour, the length of day for this January 1st. So this is for the assignment 3. Now we are coming to assignment number 4. So in assignment 4, again with this insulation on a tilted flat plane. So this first we see the estimation of energy, solar energy on tilted horizon for flat plane. So the first problem from this assignment 4 is the insulation along the normal axis to the horizon plane is 1 kilowatt per meter square. It is given this LZ value, and one tilted horizon plane makes an angle of 20 degree. This tilted horizon plane. So this is tilted horizon plane makes an angle 20 degree with horizon plane. What is the insulation along the normal axis to the tilted horizon plane? Answer up to this one place. So they're asking about ln value. So ln value will be ln Lz cos beta. So cos beta is given as 20 degrees. This angle and this angle will be equal. So it is 0.9396 kilowatt per meter square. So the range for this problem will be 0.92 into 0.95. Next problem is that what is the air mass index for the zenith angle of 20 degree. So L value we know that 1 upon cos theta z. So it is 1.064. So air mass index is AM 1.064. The next problem is little bit lengthy. Here they are asking about the tilt angle of the solar collector, tilt factor. They are asking about tilt factor, and they have given this declination angle 30 degree, latitude angle 27 degree, tilt angle 25 degree. So tilt factor is we know that HOT upon H naught, HOT upon H naught is cos phi minus beta upon cos phi sin omega SRT minus omega SRT cos omega SRT upon sin omega SR minus omega SR cos omega SR. So first find omega SR. Omega SR is cos inverse minus tan phi tan delta. So SR will come as cos inverse minus 0.1176. So cos of omega SR is 96.755 degree or 1.688 radian. Omega SR beta will be inside, it is cos tan phi minus beta, tan phi minus beta into tan delta. So in place of phi, you substitute phi minus beta. So you will get this 90.462 degree or 1.757886 radian. And omega SRT is minimum of omega SR, omega SR beta. So it will be 90.462 degree or 1.5786 radian. So therefore, tilt factor will be, if we substitute all this value, so we will get tilt factor 0.953. In the next problem, they are asking about the incident energy on a non-tilted horizon plane with atmospheric depth without considering diffusion and reflection effect. So they're asking about H naught. So for finding H naught, we know the expression 24 up into L upon pi cos phi cos dot sin omega SR plus omega SR sin phi sin delta. And tilt factor is H upon H naught. So we find this H naught and we substitute here because we have already, because this tilt factor is given. Because this, clearness index is given. This index is given and clearness index is HA upon H naught. So let us first find this H naught, and H naught expression is this one. And for H naught, we have to find this insulation on that day. Insulation on that day is 1.37 LSC into 1.1 plus 0.03 cos 360 N upon 365. And for that day, since, and for finding N, we have to use this declination angle expression, and declination angle given 13 degree. From this declination angle, we'll find the N value. So N we got 114, and now we will find the insulation on that day. So insulation will come as 1.41 kilowatt per meter square. So phi is 27 degree, omega SR we already find in the previous problem. Now we will substitute all these value here, H naught. So phi is 27 degree, del is 13 degree, and omega SR is 96.755 degree, and omega SR is in radian. You have to substitute here radian 1.688 and sine phi sine del. So you will get H naught equal to 11.14 kilowatt hour per meter square. And this clearness index value is HA upon H naught. So HA, we will get this incident energy with atmospheric effect. So it will be get into H naught. So it will be 0.8 into 11.14. That value is 8.915 kilowatt hour per meter square. Now in the next problem, they are asking about this solar collector experience in diffused incident energy. So they are asking about SD, and we know from curve fit relation is this SD upon HA will come as 0.0096, and HA we got from the previous problem 8.7. So HD will come as 0.8352 kilowatt hour per meter square, and HD dash will be HD into 1 plus cos beta into 0.5. So it will come as 0.796 kilowatt hour per meter square. What will be the minimum reflection coefficient is considered for plane surface? Discuss in week 4 lecture. So this reflection coefficient is considered from 0.1 to 0.7. The minimum value is 0.1. In the next problem, for the curve fitting clearness index, for the curve fitting glass index, consider the following data. KT this and B is this, and tau is given from this range. KT is A1 sin tau, and A1 is A1 plus A2x, where x is B. What is the value of epsilon A2? Epsilon of x is absolute value of x. So we'll find at the boundary. So sine pi by 2 is 1 and sine 3 pi by 2 minus 1. So at tau is equal to pi by 2, KT will come as 0.6. KT is given as 0.6. So if you substitute here KTE, then A1 will come as 0.6, and at tau equal to 3 pi by 2, this A1 is come as minus 0.7. And since A1 is given as AM plus A2x, so it is, and x is B, so A1 is equal to A1 plus A2B. Now at pi by 2 and 3 pi by 2, we will get these two relations. And from here, from 1 and 2, we will get A1 and A2 value. Therefore, we will get A1 as 1.9 minus 1.36. Now we compare this epsilon of A2 will come as 1.3. And this epsilon of A1 will come as 1.9. Now they are asking about this mean square error. So mean square error will be this actual value minus estimated value. So actual value and minus estimated value whole square. So actual value 0.6 at pi by 2. So an estimated value is 1.9 minus 1.3 sine pi by 2, because sine pi by 2 is 1, and this A1, A2 and B value varies at pi by 2 and 3 pi by 2. So B value is given as 1 and 2. So B value is given as pi by 2 1, and B value is given as 3 pi by 2 as 2. So this we substitute these values at both the range. At pi by 2 and 3 pi by 2, you will get this mean square error at 0. Now in the next problem, if the clearness index is 0.1, what is the ratio of energy incident on flat cutter without an atmosphere to that with an atmosphere will be? So we know that clearness index is HA upon H naught, and they're asking about H naught upon HA. So it is the reciprocal of clearness index. So it is 10. The answer is 10. So we have covered till the big four. Now let us see the big five. So in big three and big four, there are some expression you need to remember. I don't know whether they will provide in exam or not, but this expression is typical, means commonly used, this declination expression and this incident energy value and this tilt factor, many pro and some expressions are easy like this L. Yes, it's very, I don't know whether they will provide or not. Whatever the written discussion forum, that is only confirmed. Discussion forum, all the members are there. So they will, whatever they wrote, you can ask that, means whether this type of problem will given or not, will be uh, expression will be given or not. I think some numerical problems may they provide, but not this typical commonly used expression they will provide. So in big three, big four, little bit some problems are quite a bit lengthy. From assignment 5, a little bit easier part comes. So let us see the first problem from assignment 5. So in this part, they have given the energy. They have given the minimum solar energy available on the PV array is 5.4 kilowatt hour per meter square per day. And efficiency of the PV array is 0.20%. Maintenance area is 30% of the state area. Calculate the state area to meet the load demand of 2.5 kilowatt hour per day. So the interesting area expression is this one. This PV array energy upon this efficiency of PV into this solar energy available on this array. So this is the intrinsic area, and intrinsic area will come as 2.3148 meter square. And state area is sum of intrinsic area plus maintenance area. And maintenance area is given as 0.3 state area. So state area will come as 2.3148 upon 0.7. So the answer is 3.306 meter square. So this is important. How to find the intrinsic area? Intrinsic area is the ratio of this load demand upon this solar energy available into this efficiency of PV system, PV array. Which of the following does not come under the category of secondary cells? Lithium ion is secondary cell, nickel cadmium is secondary cell, nickel nickel hydride is secondary cell, chromic acid cell is primary cell. So D option is correct. What is the SOC at the instant if this date of discharge given? So date of discharge given 45%. So this expression is easier. SOC is equal to 1 minus date of discharge upon 100 into 100%. So it is 55%. So it is subtraction of depth of discharge percentage. So you will get SOC percentage. The capacity of battery is 6 ampere hour. The C rate of battery is 4C. What is the maximum discharge rate of battery from the given option? So the capacity is 6 ampere hour, and this we know that if the C rate is given like this, if something given this right hand side, then you have to divide. If something written on the left hand side, you have to multiply. Then multiply with this capacity of battery, which is coming 24 ampere. So this discharge rate is discharge current is 24 ampere, and this, so to find the time, you have to multiply with 24 ampere into X number of hours. So it will use capacity of battery, and X hour equal to 6 upon 24 hour, it is 15 minutes. Now let us see the next problem. In this problem, it is very simple. It is based upon the efficiency of the system from the PV to the battery. So efficiency of system is the power, the energy being provided to the load upon the energy being supplied by the PV. So the energy being supplied to the load upon load plus electrical to chemical conversion, that is battery inside the battery, and this chemical to electrical conversion that come again inside the battery. The relation is for this electrical to energy conversion is given as 16% of the total load energy, and while the chemical to electrical energy loss is given as 18% of the load energy. So we will get this expression, and you can simply get the efficiency as 74.63%. Now, which of the following battery has least energy density? So lead AC has least energy density, while this lithium polymer has highest energy density among the given option. This nickel metal hydride has 55 watt hour K per kg, and sodium sulfur has 100 watt hour per kg. So this least energy density is lead acid, while among the given option, highest energy density is lithium polymer. So coming to the next problem, here this C rate, a battery with 15 ampere hour capacity has a C rate of 3C. With the battery discharge current of 75 ampere, what will the discharge time of the battery at this current? Here you have to follow the I square T curve for high discharge rate. So C is equal to I square T curve. Battery capacity is given as 15 ampere hour, 75 square, and you have to find the discharge time. So T will be 15 upon 75 square. So this will give you in hour. So you have to multiply with 60 minutes. So it will come in as 0.16 minute. So this is 0.16 minute is the discharge time. So let us see the next problem. In this problem, they have asked about the speed of flywheel, the energy input the motor in kilowatt hour. So E is equal to half j omega square. We know that energy contained within flywheel, and j is the inertia and omega is the rotational speed. So omega is 6000 rpm. So it will be 2.100 radian per second. Energy stored, we substitute this value j as 10 and omega 2.100. So it will coming as in joule or watt second. Here you have to convert in kilowatt hour because they are asking in kilowatt hour. So to convert this kilowatt hour, you have to first divide by 1000 to get in kilowatt, and to convert second to hour, you have to divide by 3600. So you will get 0.5483 kilowatt hour. And here also omega given in 600 rpm. So first you have to convert in radian per second. So it is very important that what are the values you are substituting and what are values they are getting, you are getting in the final range. So this this inertia value is given in kg meter square. Kg meter square. So this value is given as 10 kg meter square, and this omega is given in radian per second, rotational speed. So first 600 rpm convert to radian per second. So first convert to rps. So radian per second, radian per minute to radian per second, you have to divide by 60. So you get 100 rps. And in one revolution, you have 2 pi 2 pi radian. So one revolution is 2 pi radian. So it is 2 pi 100 radian per second. So this is revolution per second. So therefore, the energy stored is 0.5483 kilowatt hour. So the energy input to the motor will be, it will be divided by this efficiency, that is 0.6, so it will be 0.685 kilowatt hour. So the answer is 0.6 into, the range is 0.6 to 0.75. So this is the stored energy inside the flywheel. So the what is the energy input to the motor? So we have to divide with efficiency. So coming to the next problem here, they are asking about this battery capacity. And in this problem, they have given this battery bank, depth of discharge, number of days of autonomy, load connected to the battery demands a load of 500 watt hour, and night load is 1000 watt hour. Consider the battery efficiency 70%. So we know the expression for designing the PV. So the total requirement of load is WH night upon efficiency of battery. So here this is designing of battery. So this, and for the days of autonomy, you have to multiply with Na and divide whole this day and night by the efficiency of battery. So you will get this 12,142.86 watt hour, and this ampere hour value of battery will be this WH load, the energy requirement by the load upon date of discharge into the nominal voltage. So we'll get this ampere hour rating of the battery. So this problem is from designing of battery. So here both these autonomous days are considered and the efficiency of batteries is considered. Now in this problem they have considered days of autonomy as 0, and this question has eliminated from the final evaluation, and this peak power output of PV panel they are asking. So let us find this. This is from designing of PV. So what should be the peak, what should be the energy requirement from PV, that is during day hour plus during night hour. This should be this should do of this amount of energy should go into the battery. So WH night upon efficiency of battery. So 500 plus 1/3 upon 0.7. So it is 1928.57 watt hour. And peak watt will be the energy requirement from the PV upon number of hours for this solar energy available. And solar energy available for 5.4 hours. So this array peak watt will be 357.14 watt. So the last two problems are important. So this first problem is from the designing of battery, and this problem is from designing of PV panel. So designing of battery, we have to consider the night time and this the days of autonomy. And for designing of PV, we have to consider this. We have to consider the power being supplied during daytime, and this power being supplied to the battery to deliver the power during night time. So this is the formula for designing of battery and designing of PV panel, PV array. So since I have not, I was not able to solve all the problems due to time constraint. So till big 5, I have solved the problem. Yes, I will upload till this big 5, and other part you will just go through on this uploaded by the NPTEL team. So I have taken the help from this only while solving the problem. but you have to solve yourself also. For this is for big 7, they have here they have shown the problems for the finding the input resistance for the battery. We can see some theoretical problems like in problem 9. Ramesh, your mic is on. Please turn it off. If you want to say something, then you can speak.
Uh, Actually, sir, in uh, assignments 5, question number 9 and 10, like designing parts, uh, what's the important in the formula?
This a formula is very easy. Means you have, if you know like the energy requirement by the load. First, you have to find the energy requirement by load. And what should the energy requirement by load from the battery that being supplied by night in the night, because in the night this PV is unavailable. So that's why first energy we consider for the night time, and the autonomous days this PV is also PV is unavailable for the day also. So PV is unavailable, so you have to consider this daytime also with night, and it should get multiplied with number of autonomous days. So that is for designing of the battery. And if you know the energy requirement by load from the battery, then you can find this ampere hour rating of the battery. So this expression is quite a little bit easy. And for the PV, if you design the PV, then for the designing of PV, then this day part comes, because this energy requirement during daytime, this should be supplied by the PV because the sun is available. So this day part will comes, and this night time, this night energy that being supplied to the battery, means whatever the energy requirement during night time, it should be charged for the battery. Battery should be charged to that amount of energy that it can supply in night time. So it is WS day plus WS night upon efficiency of battery. And here this for PV for battery, you have night requirement during night time plus requirement during autonomous days will be considered. While this for PV requirement during daytime plus requirement of energy being given to the battery to deliver the power during night time. So this is the case. Okay, Ramesh.
Okay, sir. Thank you.
So I would say that go all through all assignments, and for revision it is good for us. And whatever I am whatever I am telling you, don't think like it is confirmed. So later time you cannot say that I have said you that only just focus on assignment. So don't take means like I am just, it is my personal point of view. You have to means from the NPTEL side there is nothing like this. They may ask from any part of the book or any part of the video lectures. They may ask from the syllabus. So when I was used to give the NPTEL exam, I used to first revise the assignment part, and after assignment part, later we see some more assignment, and then we see the video lecture also. So what are the conclusion? Conclusion is that whatever I am speaking, that just focus on these, or what are the number of questions that I just spoken in how you can say, just spoken in random way, that is not fixed. I cannot decide anything for this course. I am just a TA. So I am just here
Assignment
to help you. Yeah,
assignments means in a single week there are 4 assignments. One from NEPTL and 3 for practice
yeah. And
assignments.
whatever we are solving, that are previous year assignment. That are also important. So the first is your current assignment, and what we are solving, that are previous assignment, because this course is not a new course. This course is being running for 7 or 8 years, means a very long time. So we are
Previous
discussing the previous assignment.
previous year assignments we get from the Google.
No, you cannot get. If you have enrolled during that time, then you can only get, because if you once enrolled, it will get fixed to your account.
Yeah,
You
yeah,
cannot get.
we are enrolled, but where it's so the previous year questions.
Yeah, previous I just, if you have not enrolled last year, then you cannot get. Like suppose these are the courses I have enrolled last time. Just I have taken, but I have not paid the payment. So that is also okay. You can see the previous problem. Like suppose this type of these courses I have taken earlier. So this will show in my account section. So from here you can get back to the previous year question also. Like this one is the previous year course, previous year assignment. So this course is NOC 23. So this is 2023 year assignment. So in that assignment, the questions are different as this according as from this assignment. I think some problem is there. So these are the things that means I'm whatever I've discussed means whatever things I'm telling about exam, that is not fixed. So believe me, don't believe on me blindly. I'm just here to give you the concept how to solve the problem. So whatever thing I'm telling, that number of problems and whatever the numerical type, objective type, that is not I'm deciding. I'm just the TA, right? I hope all of you got it. So whatever things you are getting from the mail or getting in the course structure, that is confirmed only. Other things, what I'm telling, that is not fixed. I am not the head of this course. Which time solution? Earlier assignment you want to ask. Okay. That is similar. That whatever we have discussed, same problems that we have discussed in this tutorial problems, that are same. You don't need to bother about this. And all PMRFTA that are discussing the previous assignment. Okay, all the best for your exam. And it's very good to interact with you all. Miss like Ramesh, Mohan, Chindam, Rajnikant, and all are always available during tutorials. Neeraj, RK, and during the starting days, everyone was used to attend, but now the 3 or 4 attendee. So hope we will sometime later. So happy Diwali to all also, because I hope we don't know we will be when we are going to. There is no nothing we are knowing.
Thank you, sir.
Okay, nice to interact with you all.
Happy Diwali to you also, sir. And
Thank
thanks
you.
for your support and uh, learning
Yeah.
lots of things. Thank you.
Okay, welcome. Okay, good luck for your exam. I am just closing the session. Happy Diwali.
Thank you, sir. Thank you, sir.